So it's widely accepted in the scientific community and in at least one political party in this country that the rising carbon emissions in our atmosphere are a serious problem. A big contributor to this fact is that when humans find carbon buried beneath the surface of the earth, we like to bring it up and burn it. We do this by putting it in our cars and in our industries to help power them, but this, as you know, creates carbon dioxide into our atmosphere. One way that we're looking to alleviate this problem is by taking already available carbon in waste sources of the industries of local industries here in New England and converting it into a high energy density liquid transportation fuel, or biodiesel. In the top left, you see some shells. Crab, lobster, and shrimp shells are generated in abundance as a waste stream from local seafood industries. On the right, you see a few molecules. About 40% of seafood waste, or the shells of these organisms, are actually comprised of chitin and chitosan, which are the molecules you see in the top right. These are long-chain polysaccharides, linked sugars, where the primary component of these chains is N-acetylglucosamine, or NAG, an amino sugar. You can take NAG and feed it to Rhodococcus opacus, the bacterium you see in the bottom right, and it can grow to incredibly high cell culture densities. It grows very robustly on NAG. Importantly, at very high cell culture densities, you can starve it from the essential nutrient phosphorus, and it essentially triggers a genetic response using 290 genes that basically tells the cell, start accumulating nitrogen and storing it as fat rather than using it for other metabolic processes. These fats, or lipids, specifically known as triacylglycerols, are shown in the lower left. These are 3 fatty acids connected to a glycerol backbone, which can be put through a chemical conversion process known as transesterification. The product of this is glycerol and 3 fatty acid methyl esters. You can feed glycerol back to Rhodococcus opacus as a nutrient, but the fatty acid methyl esters are biodiesel. You can put them directly into your conventional diesel engine with no modifications and burn it as fuel. Importantly, it's currently recommended you use biodiesel in a 20 to 80% blend with conventional diesel for advanced fuel properties like a cleaner burn with no detectable differences in fuel efficiency. The main problem we're currently working on is the fact that Rhodococcus opacus cannot depolymerize chitin. It cannot break down these large polysaccharides into these small sugar units. However, a different bacterium actually can very efficiently using only 5 genes. So our aim is to take these 5 genes, transfer them into Rhodococcus opacus to develop a bacterium that can, in a single batch process, convert seafood waste into the more environmentally responsible biodiesel to power our cars and our industries. Thank you.